So I'm gonna share my screen now. So I'm very excited today to do this clouds webinar, and let's get into it. So the outline for today, we're gonna start, by doing some theory. So in part one, we're gonna look at the cloud classification, the cloud types, the naming. Then part two is gonna be cloud formation, learn about the physics. And then we're going to move in something more practical, how you guys can use this knowledge of the clouds on the water. So part three is going to be the impact of clouds on the wind at the surface. And the last part, the best part, in my opinion, and you want to stick until the end, is the impact of clouds on sailing. So let's go now with the cloud classification and the naming. So I put those names on the screen, and maybe some of you guys know those names, but from others, it's just like, okay, what does it mean? Don't worry, we're gonna cover this, and in about 3 minutes, it's all gonna make sense, and you will know all about cloud naming. So for cloud classification, there are basically just 3 criteria that you need to know. So the first one is the cloud height. Okay, the cloud height, very important. This is a distance between the ground and the base of the cloud. Okay, this distance here. It has nothing to do with how tall is the cloud or how thick is the cloud. So we have 3 categories. What we call a high cloud. It's above, so the bottom of the cloud is above 6,000 meters. And if it is the case, the name of the cloud will start with the prefix Cyro. Then we go into the middle cloud. It's roughly the middle of the troposphere. It's 2,000 to 6,000 meters, and the prefix is Alto. And the low clouds, the most interesting clouds, in my opinion, are the one below 2,000 meters, and easy enough, there is no prefix. So just, I want to remember what to take out of this slide is the cloud height is the height of the bottom of the cloud. Then the second criteria for the cloud naming is the cloud shape. Basically, there are 2 categories, the strato and the cumulo. So this comes from the Latin. I'm not going to spend time on this, but strato, basically, it means to spread out or to lay down. So myself, I like to remember it as a layer. That's why I put the picture of this big rock. So in English, it's a stratum, but a big layer like this is what we refer to a certain type of cloud that looks like a layer. And the second type is a cumulo. Cumulo means heap, pile, or mass. That's why I choose a picture of a heap spoon. And this is just a cloud by itself, not as a layer. So as a takeaway, personally, this is how I remember it. So strato clouds, you cannot really count the clouds because they are just one big layer. A cumulo cloud, you can count them, okay, individual clouds, and potentially you can fall asleep. Let's move to the last criteria, which is very easy. Either the cloud is raining or not. If the cloud is raining, we just add the word nimbo inside the cloud name. So now that this is clear, I'm showing you here a slide from NOAA that just summarizes the 10 most common clouds. So let's go together. Let's start with the low-level clouds. So as we said before, we are below 2,000 feet, 2,000 meters, which is roughly 6,000 feet. This is the altitude where small airplanes fly. And so one of the first cloud is the common cumulus cloud. It's a cloud which is well defined with edges, and you can count it. The stratus, this is a layer cloud, as you can see here. Okay. Another cloud, and a very important one, is the cumulonimbus. So it's nimbus, so it means there is rain associated with it. And this cloud, even if it's very tall and it can extend up to 10 kilometers high, it is still a low-level cloud because the cloud base is below the 2,000 meters, okay? So now let's move into the middle clouds. So we have to add the prefix alto. So we have the alto cumulus right here. So as you can see, those are individual clouds that you can roughly count, but they still have defined edges. But if you look at the alto stratus, this is a big layer and you cannot count, just a big, thick layer. Now let's move to the high clouds. So we are high into the troposphere. This is where big airplanes are flying. We have here and we have to put the prefix Cyro. So we got the Cyro cumulus. So here again, it's more difficult, but you can still see the edges of the cloud and you can still kind of count them, okay? But on the other hand, the Cirro altus is just a big layer, very, very high in the atmosphere. What is also specific about the cirrostratus is if there is a sun or the light, it will show as a halo behind the altostratus. Okay, and we have also the cirrus, which is not a cumulus, not a stratus. It's just a very specific clouds that looks like those fibers that you can see at the top of the troposphere. Okay, so maybe you guys noticed, but actually I forgot two clouds, and this is on purpose. So I forgot this one. So this one is called the stratocumulus. And maybe your question is going to be, Arnaud, is it a stratus or is it a cumulus? The reality is Mother Nature, it's not always in categories, and this one is just something in between, okay? You cannot really count it, and it's not really a layer. It's just something in the between. And the reality is the majority of the clouds in the sky are stratocumulus, okay? And the last one I didn't mention is nimbostratus. The nimbostratus, in my opinion, and this is why I put it in green, this is a low level clouds, okay, because the bottom of the cloud is below 2,000 meters. So in my opinion, I classify it as a low level cloud, but NOAA, for some reason, decided to put it here in the middle clouds. I do believe it's because some of them are low, but you also have nimbostratus with the bottom of the cloud in this category. So I hope this kind of makes sense. To be completely honest with you, naming the clouds is not what's going to help you to sell better, but it's always nice to have this in your toolkit. So now let's move in part two, which is the cloud formation. So here we are dealing with the physics of a cloud. How does a cloud appear in the sky? So the first thing, in my opinion, is to realize that a cloud is first created by rising air. This is something very important. The air rises, and as the air rises, the pressure decreases, air expands, and therefore temperature cools down. When the air temperature decreases, it's going to reach a temperature we call the dew point. The dew point is when humidity is 100%. And the water vapor inside the air parcel is going to start to condensate. The condensation creates liquid water, tiny droplets that are visible to the eye, and this is the cloud that we see. Actually, this is a cloud base. The condensation, something important to know, is it actually releases energy, okay? And the energy which is going to be released, it's going to help the air parcel to keep rising. It's going to boost the upward motion because this air parcel is warmer than the surrounding. So because of this, the cloud will then extend vertically. It will build up in height and grow. At one point, the air will stop rising because there is no more air temperature difference. And this is the top of the cloud, okay? Usually this is where you have an air temperature inversion happening, and this is a cloud sailing. So here I put this picture of paragliders, okay? And why I put this is because those people doing these sports, what they are looking is they are looking for lift, for upward motion of the atmosphere. And what they do is they go around clouds looking for those lifts. They actually do not go inside the cloud because it can be too dangerous. And usually they just stay and circle around clouds in order to find this rising air. So in this plot, I'm not going to go in too much details. I just wanted to repeat once again how the cloud forms very simply. The first time at the beginning, you just have an air parcel. It's air, but it has water vapor inside, and something make it rise. We're going to study this later. There is a cool down. Dew point is reached, and droplets starts to show, even ice crystals. And the energy that is being released during the condensations helps to identify the updraft. Okay, so those two things, the 4 and 5, this is the cloud dynamics. It's actually very complicated. Weather model try to simulate this, and it's out of scope for this presentation. What I would like us to do today is to focus on this, is why does the air rise in the first place? Because this has definitely impact on the wind and also for us sailing. So let's study the different modes why you may have air rising. So one of the first mode is a convection, the heating, okay? So during the day, on a hot summer day, the sun heats the earth and you've got warmer air bubbles develop at the surface. Usually it happens, if you have rocks, sand, maybe roads, a lot of heating is created. This warmer air has a lower density than the surrounding air, which is not heated as much. For example, if you have water or forest, okay? This warmer air is more buoyant and then it rises and it creates a cloud. And everybody that has been sailing in summer knows this because this is how the sea breeze works, okay? On this picture, during the day, there is more heating over the island, over land, than over the water. This is why you have this cloud formation over land, because air is rising over land. Let's move into another mode why you may have air rising. The reason is topography, okay? If you have surface winds that encounter a hill, a mountain, any obstacles, the air will just hit the slope and it will rise and a cloud may form. So here I'm showing an example, okay? So this is a Cape Town, the Table Mountain, and you can see, so what's happening in this picture is you have a wind blowing above the water. The air is moist, it hits the slope and it rises and it creates the beginning of the cloud. Okay, so right here where the cloud begins, dew point is reached. But the question you may have is, this cloud doesn't look like a typical cloud. It's actually a very good looking cloud, but what is very special here is this cloud doesn't build up, okay? It does not have a vertical expansion. Something is here preventing the air from rising. It just rises a little bit because of the topography, and then it stops ascending. So in Cape Town or also in Gibraltar, what's happening is the ocean is actually very cold compared to the warmer air. And so the air which is blowing just above the water is actually quite cold, okay? And so this air rises, reach the dew points, but when it reaches this area, the air above is actually warmer, okay? And the warmer air is called a temperature inversion, but it just means that it acts as a ceiling, okay, a glass ceiling forbidding the upward motion. Maybe you notice it in winter when people are burning firewood, okay, you may see the air, the smoke rising, and in some certain categories, certain circumstances, the air will stop rising because it hits a ceiling. There is a temperature inversion. Another example of clouds that are created by topography are this one. where the air is unstable. Okay, here it was stable, here it's unstable. So the topography give a little bit of lift, and then the unstable air and the condensation will keep the building of the cloud, creating a big cumulonimbus, okay, and getting some rain, okay? So this type of situation is, for example, what's happening in the Canary Islands, for example, the island of Tenerife, where I like to go sailing. So on one side of the island, you have a lot of rain, you have big forests, and on the downside, on the lee side, actually the air is very dry. This is a fun effect. And on the south side of Tenerife, it's actually a desert. There is no tree. Now let's finish with one of the third mode of air rising, which is frontal interaction. So when you have two air masses with different temperatures, the cold air will lift up the warm air, okay? And where this happen, you have a line of clouds, and this is a front, okay? I like to use analogy, and you can make an analogy, for example, with geology and tectonic plates. It's exactly like this. You've got one plate, which is more dense than the other, and this one, when they're gonna hit each other, they're gonna push it up, okay? Now let's take some time and study briefly the warm front, and especially the clouds that you have in a warm front. So on this plot, you see the warm front here. This is a symbol. It means that you have warm air on the left and cold air on the right. And the movement of the front is given by those symbols. And here it moves from the left to the right, okay? So what is very specific with warm front is the rising of the warm air is pretty steady. It's on a nice slope, as you can see here. And this impacts on the type of rain and especially on the type of clouds, okay? So let's say we are at sea, we are right here, and the front is coming toward us. What will the people on the boats, what clouds will they see? So first of all, they will see high clouds, cirrus. And actually having cirrus can be an indication of a warm front coming, okay? And then as you can see, little by little, we're gonna have lower clouds. So this is altitude. Then we're gonna have cirrostratus, which is mid-level cloud. Then we're gonna get altostratus. And finally, we're gonna have the nimbostratus. This is when it's gonna start raining, okay? And what is specific with a warm front is you have rain, no showers, just constant rain, can be a lot of rain. And finally, you're gonna have a stratus. So one thing to remember is within a warm front, you have stratus, big layers of clouds. And at the back, after the front has passed, you have actually the stratocumulus. Okay, now let's have a look at the cold front, which is a complete different beast. Okay, the cold front, this is the cold air rising the warm air. And this rising is much more dynamic, much more brutal, and it will create different type of clouds and different types of rain, okay? So here on this case, we've got the cold air here on the left and the warm air on the right. So once again, we are sitting here and the cold front is coming toward us. So what type of clouds are we gonna see? Actually, we're gonna have a pretty decent night sky, maybe a couple of clouds, but very quickly, we're gonna have this one, the big cumulonimbus, which is characterized by showers and potentially lightning. So this is a very brutal, the wind is gonna change pretty rapidly, okay? And after the showers are passed, we're still gonna have some clouds and we're gonna have cumulus and altocumulus. So something to remember is a cold front has cumulus and the warm front has more stratus. All right, so we have finished with the theory. I think you guys now know as much as me about clouds. So let's get into some practice. Try to use this theory applied to the wind at the surface and to sailing. So here, first of all, I want us to focus on low clouds. So the low clouds, as we showed before, are the closest to the ground and to the sea. Therefore, those clouds has the most direct influence on the winds at the surface, especially in the short term. So basically, for a sailor, in my opinion, you should prioritize low-level clouds to determine to guess how the wind is going to change in the next few hours. I'm not saying that those mid-level and high-level clouds are not important, but they are just further away from the surface, and therefore they have less influence on the winds at the surface. Here is a recap. Low-level clouds have an influence on a sailboat in the next few hours, okay? Mid-level, it's more in the next 3 to 6 hours. The high-level clouds, like we said before, remember, with the warm front and the cirrus, if you see the cirrus, it doesn't mean you're going to have a warm front in the next hour. It's more 12 hours or a day. So here I am just showing this slide. So those are the 3 stages of the cumulonimbus. It's just, I want you to remember this, and we're actually going to study that now every type of cloud. But just so you know, a cumulonimbus starts just as a cumulus at the beginning. This is a towering stage with the updraft. Then there is a maturing stage when it starts to rain at the back. And then there is a dissipating stage. Now let's go and study this in details. So the first type of low-level clouds that I want to focus on, so those are the cumulus. So as you remember, this is a not precipitating cloud. There is no nimbus, okay? And it can also be referred, because we want to talk about the wind, as a sucking cloud. So this cloud, the air is rising, and because it's rising, it creates an inflow at the surface, okay? This convergence is sucking air in, and you can see it, as a chimney. So here in red, I'm showing the wind at the surface going toward the center of the cloud. The strength of this surface winds depends on a few factors. One of them, for example, is the vertical development of the cloud, okay? If you see a cloud which is growing in height, looks very puffy, it means the updraft is strong, and therefore the surface wind is also strong. Also, just the size of the cloud. If you see a big cumulus, there is a good chance the sucking wind is stronger. Finally, I want to highlight that typically sucking clouds are stronger in the tropics, and they can create, a surface flow that a sailor will feel. But in mid-latitude, we sail in the US, in Europe, in New Zealand. From our experience, rarely a sucking cloud will have a significant impact when you are sailing. Something to remember. So here is an example of a sucking cloud. So this is, in my opinion, a good-looking cloud. But if you see this in the sky, there is not much vertical development, and for me, it's not very relevant in terms of change. It will not change the wind, and you can sail around it. Nothing will happen. On the opposite side, if you are sailing, probably in the tropics, you may see a cloud like this. Okay. It's vertically extending. It's not raining yet, but it's still very dark. There is definitely a strong updraft below. It's also quite close to the water surface. So let's say we are the person taking the picture. The wind you will feel being sucked into the cloud will come from your back and will go toward the center of the cloud. Now let's move in the type 2. So this is a precipitating cloud. This is also a nimbostratus, as we studied before. And here we use a terminology blowing cloud. So the rain is falling and it creates a downward flow, okay? When this downward flow hits the surface, it creates an outflow at the surface, okay? This is in red, the outflow. Something important to know is the downdraft is stronger than the updraft, and therefore the surface winds will be stronger for a blowing cloud than a sucking cloud. So basically, if it starts raining, it will have more influence on the winds at the surface, okay? The more intense the rain is, the stronger the downdraft and the outflow at the surface. And also here is a tip for you, is typically true wind speed increase and true wind direction shift actually arrive before the rain. Doesn't happen always, but it's usually the case. Okay, so here is a picture of a blowing cloud. So it's definitely raining under the cloud. If the person taking the picture is feeling the wind, okay, coming from the cloud in his face, okay? And you can see definitely there is wind on the water with those white caps. All right, so now we move into the cumulonimbus, and this gets more complicated, unfortunately. Okay, it's both a sucking and a blowing cloud. What does it mean? So a cumulonimbus has one side of the cloud with the updraft, the wind rising, and on this side, a downdraft, okay? So the wind at the surface is actually more complex, as you can see, depending where you are located, okay? Usually the updraft is at the front of the cumulonimbus. What will you encounter first if a cumulonimbus comes straight at you, and the downdraft is at the back. Okay, so cumulonimbus cloud, also called the thunderstorm, can produce rainfall, heavy rainfall and lightning, okay? And it can also produce severe wind speeds and heavy showers. And we will actually study this even further later on, okay? Here is an example. And here this is a major, okay? This is a major cumulonimbus, very well developed. There is even something we've called the shelf cloud. The shelf cloud is part of the cumulonimbus, okay? This is it, okay? Such a cloud, if you see this is a sign of an extreme weather event coming your way. Especially the shelf cloud is associated with squall lines. And this is the main thread of any squall line is actually the strong wind gusts associated with it. So if you are sailing, you need to pay special attention at this kind of shelf cloud. Now, another type of cloud you may see when you are sailing is the cloud line. Okay, sometimes in the sign in the sky, you will see clouds organizing themselves in the line. What does it mean? It means that on both sides of the cloud, you've got some different wind coming and converging and creating an updraft. Thus, it pushes the air upward and create a cloud, okay? There are two types of cloud line. I'm not going to go into details here, the confluence and the convergence cloud lines, but those things are discussed in the help article about clouds. And for those really interested, you can go and see a lot of explanation about cloud lines. Similarly, the clouds associated with the sea breeze, we are not going to cover it here. But if you go to help.predictwind.com, this is our help center, you will find, first of all, our article about clouds. If you open it up, by the way, you can read it in different languages, English, French, Spanish, Italian, and German. There is a drop-down menu at the top, so it might be useful to have in your mother tongue. But we have also a specific article, a pretty long one, about the sea breeze and the clouds in a sea breeze. So now we are done with the surface winds, and I'm going to go into the good stuff, okay? The impact of clouds on sailing. We're going to give concrete case studies, pictures, articles to try to make use of all this theory. Okay, so let's start with exercise number 1. Okay, so let's say, hold on. Let's say you are sailing and you are into a steady 10-knot breeze. Okay, and you have a sucking cloud coming straight in your direction, which is also the direction of the leading wind. Okay, and makes an assumption that the inflow creating by the sucking cloud is 2 knots. Okay. So I put all of this in just this. Okay, so you got the main wind of 10 knots. You've got the updraft creating 2 knots converging toward here. And here is the question. If you are sailing, okay, what wind will you have if you are in A, in B, or in C? So let's do this together. Okay, so let's start. If you are in A, what wind do you have? So it's like adding vectors. So you need to add this 10 knot wind from the left, and you need here to subtract these 2 knots. So actually you are experiencing 10 minus 2, 8 knots. So when the cloud is approaching, the sailor experienced a decrease in the wind because the sucking of the air is fighting against the main flow. Okay. When you are just under the cloud, here, there is no surface flow, just updraft, so you have the 10 knots. And when you are in C, as you can see, those 2 vectors add up. It means you are feeling more wind at the back of the cloud. So just to remember, if you are way above the cloud, you got 10 knots, going down to 8, going back to 10, then ending up to 12. And when you are very far away, you will go back to the 10 knots. Okay. Now let's take another example. So this time the sucking cloud is not going to go straight at you, but it's going to come on the side. And let's assume the right-hand side. Okay. And this is the same question. What wind will you expect? So let's say we are here in A, and this sucking cloud is coming on your right-hand side. So what wind will you experience first? So we're going to add these big 10 knots here, and we're going to subtract this here. So as you can see, it will create 2 things. First of all, because you have a component which is against the main flow, the wind will decrease a little bit. That's why I put 10 minus. But the big thing here is, as you can see, the axis of the wind vector is going to change. It's going to be pushed on this side, which is actually a left shift. What happens in B? Same, you got the left shift, but on this case, there is no fighting, and the wind is actually going to increase a little bit, 10 plus. And in C, you actually have even more wind because this wind is going along the way of this one. Okay, so this type of situation, a sucking cloud coming on your right-hand side associated with a left shift, a decrease of the wind, and then an increase of the wind as it's passing over you. Okay, so let's take just an example here. Here is my question. You are at sea and you see these clouds. What do they tell you? So me, when I see at those clouds, I recognize cumulus. Okay, they do not show any big vertical movement. Okay, this one has none. This one has just a little bit. Maybe this one has a little bit. Okay. So in my case, if I see this, there is not much happening. And also those are individual cloud, very small. So it means you have some sucking here, but some sucking around here. So if I sail under this, I really have it doesn't bother me. I'm not reading the clouds. And maybe this is an opportunity here to give you like a story from my time in the America's Cup. So I was with Alinghi in Valencia in 2007. I was working with John Bilger, which was at the head of the weather team, and he's also the founder of PredictWind. And we had the sailors calling on the radio. And quite often they were asking, hey, what about this cloud? Is it going to create a shift? or whatever, a wind speed increase. And quite often, they were pointing toward those little clouds. And for us, we were on a weather boat. We had a weather network of maybe 20 buoys and land-based station studying, wind shift and wind trend, looking at data almost as a trader on the stock exchange. And I do believe that, looking at the forecast, looking at the observation is actually more relevant than looking at any cloud, especially the little one that has no influence. So here is the reply. So if those clouds, if they have any reply, it will be a very slight change in wind speed and a very slight, if any, change in wind direction. But what about this one? If I see this one, this is a different story, okay? So here is the answer, but this cloud is very puffy, a big vertical development, so there is something happening. So the answer is the wind speed decrease as the cloud is approaching because of the sucking. If you can expect a substantial wind shift, maybe 20 or 40 degrees, if it comes on the side. And as we said before, if it comes on the right-hand side, expect a left shift. And if it comes on the left, expect a right shift for a sucking cloud, meaning there is no rain, okay? It's very important. As soon as it rains, it's a different story. So if you go to our help article, you will find plenty of other exercise like this one and pictures about blowing cloud, cloud line, and etc. So feel free to go there in the following days. We're going to keep moving here. And now, I don't want to talk about those clouds that create, a wind shift or a wind speed increase by 2 knots. Now I want to move into big weather systems, okay? Big cumulonimbus, thunderstorms, and extreme weather events to look more at very strong weather conditions that has an impact, on the safety of you, of the boat, of the crew. So a cumulonimbus, also called a thunderstorm, is complex, okay? Because it has a combination of sucking and blowing. And sometimes, you can find the perfect storm, and those events can be extremely powerful and dangerous, okay? So when you see something like this, a beast like this on the horizon, you should be careful. And this is what we're gonna study now together, okay? So here is a theory. Let me move my notes here. Sorry. Okay. So typically, if a cumulonimbus comes straight at you, you will first experience the updraft and after the downdraft. Okay. This can be summarized in 3 stages. Okay. So stage 1 is when the thunderstorm is approaching. Typically, you are under warm and moist air, and the situation is generally calm. It's like the calm before the storm, okay? This is the time, where you can take preemptive actions. This is when you can reef. This is when you can prepare the boat, check the anchor, because when stage 2 happen, it's roughly too late. So the stage 2, and I'm talking here about a major cumulonimbus, okay? What you will experience is what we call the gust front, okay? So what's happening here is because you have a downdraft, the rain is cooling the air as it's coming down. And when this cold air hits the surface, it's spread out near the ground away from the raining core. The temperature drops significantly, okay? And the leading edge of this rain cool air is referred to as a gust front. And typically, it goes with very strong winds and a change of wind direction, okay? The sea state also may build up very quickly, and this is a danger zone for sailors, okay? And stage 3, the gust front has passed. This is where you get rain. It can be really rainy, it can still be strong wind, but this is less risky on this. So now let's go and study actually stage 2 with this, okay? So here you recognize the cumulonimbus. We have the downdraft at the back and the updraft at the front. But it's not exactly like I showed before. This is a major one, okay? So what's happening here is the warm air is coming this way. So typically you are here, at anchor, and conditions are quite calm. And then you may see in the horizon the gust front, okay, coming your way. So why is it so strong? Is this cold air is really rushing down vertically, because the rain can be very strong. You can have hail. So it's almost like if you are spreading a bucket of water, from 20 meters high, it will hit the ground and shoot out very, very strongly. And this is what happened here. And this is a gust front. And this is also what's happening with the shelf cloud. Okay. Here I'm using this symbol because this is a little bit like the gust front is doing. Is pushing air, cold and dense air, very, very quickly here. It's pushing also because there is a high pressure here due to this compression of the cold air. And also what is very specific with this with this front is, as you can see, this cold air and this warm air can have completely different direction, okay? It can be a 180. So you can be anchored here, protected, facing the land, but when the gust front might come, it might come from 180 and you are not anchored anymore and you have the wind coming straight onshore, okay? So what I would like to finish now is just to tell you that for the safety at sea, PredictWind, we have developed some tools, okay, to help you to help you apprehend those major events, extreme weather. And we have 5 tools. I will not have time to go into too much detail, but please feel free to contact us if you have any question on how you access it, what subscription you have. So the first tool we provide you is high resolution regional weather model. We have plenty of them. We have the PredictWind, PWG, PWE for the most popular setting coastline in the world. If you are in the US, you got NAM and HRR. In Europe, we got AROM and UKMO. So why is it so important to have high resolution regional model? It's because they give you 1 kilometer maps, for example, of the rain. And you can really see the structure, of the rain. Of course, this is a forecast, so it does not mean that the cloud will be exactly this way, but it tells you the potential of having strong cells and active convective cells. Another tool that we provide is CAPE. CAPE stands for Convective Available Potential Energy. This is the amount of fuel there is in the atmosphere. It's a measure of the instability, how the air can rise. Typically, if you got a value above 2,500 kilojoule, it's very unstable. And PredictWind provide you this kind of maps, okay? We also have a split screen. On the left, I got high resolution rain. On the right, the high resolution CAPE. And you can definitely, those cells here are definitely very active and needs to be looked out when you are at sea. Another tool that we provide is the warnings. PredictWind has developed this easy to recognize symbol that will show in various places of our ecosystem. And when you see this, you can click on it and it will give you a clear indication on the type of warning and extreme weather, like high wind against current. Another tool we provide is a GMDSS. Okay, a GMDSS is a marine forecast written by a trained meteorologist, and it's really for the safety at sea. Of course, it's text and it's for parts of the ocean. It's quite difficult to read, but PredictWind has developed the GMDSS in a graphical format that can let you see very quickly where are the major events. For example, here, there is a hurricane, and you can see it on the PredictWind offshore app. And finally, we also provide rain radar and live observation, because forecast is good, but when you are actually on the water at anchor and you got a big storm coming, forecast is too late. You need to look at what's happening right now, rain radar, and live web observation, and you can see the cells developing. This is the end of the presentation.